This video will guide you through Part A of the Groovy Google Sheets Distribution and Outliers. So first, open up the Google Sheet titled Groovy Google Sheets Distributions and Outliers from Google Classroom. Part A, we're going to make sure that you are in the tab that says Outliers. Now there is not one exclusive way to determine what is an outlier and what is not an outlier. The general agreement is that outliers are any data that is greater than this calculation. So if you take the third quartile, the value of the third quartile, and add 1.5 times the interquartile range, that is called the upper fence, and anything bigger than the upper fence would be considered an outlier. And the same if you took Q1, so the value of the first quartile, and subtract 1.5 times the interquartile range, that is called the lower fence, and any number below that is considered a lower outlier. That is not the only way to calculate outliers, that is just the most common way. And what you'll probably even find when we use Plotly is that the values that we calculate using these formulas aren't exactly the same as the numbers that are used as the upper and lower fence to calculate these outliers, but they are close. So in this example, the heights in centimeters of 1,175 students who completed the Census at School survey are recorded. We're going to use the Outliers sheet to complete this activity. So first of all, we're going to complete a histogram of the data. We're going to make the buckets 10 units, include relevant titles, and you may notice that there are some outliers over here. Don't worry about those yet. And then after that, we're going to create a box and whisker plot of the data. And again, you're going to see lots of outliers. Don't worry about that. So I'll just quickly go over again how to make the histogram. So highlight column A, insert chart, and you're going to change the chart to a histogram. And under Customize, for histogram, we're going to change the bucket size to be 10. And under Chart and Axis Titles, the chart title, we're going to make heights of students. And the horizontal axis is going to be the height in centimeters, and the vertical axis is going to be the frequency. Now, that shows more than 10 intervals, because we should have between 5 and 10 intervals, but when you have outliers, sometimes you need to show more, because otherwise if you made your bins or your bucket size to be, say, 25 or 50, so that you have less intervals, it just doesn't look right. So it's okay if you have outliers, that there may be more buckets than you want. So that is your histogram. And again, the numbers don't look exactly like the picture, but that's okay. You can go to horizontal axis. You can change the slants to be 90 degrees. And there's your histogram. Now, to make the box and whisker plot, you need to go to Plotly. Remember, the link is on our Google Sites and Google Classroom, or if you want to type it in, there's the website right there, plot.ly/create/box-plot. You're going to highlight column A, and in Plotly, you're going to put it into column A, click Trace, change scatter to be box. We're going to make it horizontal, so you're going to choose X to take the data from column A. Then space to get rid of the title, space to get rid of the y-axis. On the x-axis, we're going to title this height, and the units are centimeters. Then under style, traces, you're going to delete trace 0 because we only have one box plot. And then under points, instead of hiding the outliers, we're going to show suspected outliers. And then there is your box plot. Use whatever screen capturing tool you want. And get that, copy it, and paste it into the outlier sheet. So it's right there. So in that outlier sheet, you should have your histogram and your box plot. Again, take a look at all those outliers. You can resize this. And I'm going to show you how you can filter out the outliers and then how that will change the box plot and the histogram. Now, what I'm going to show you here, you don't have to do. But because we're going to be going back and forth from different tabs, what we would like to do is, rather than always having to come back here and highlight this data, what we're going to do is something called named ranges. So a named range means we're going to name this data height. So then whenever you do a calculation, instead of highlighting the data, you can just type in the word height. It'll make more sense when we do it. You don't have to do this. You can always go back and highlight the data yourself, but it just saves a little bit of time. So highlighting data and naming the ranges is optional, but useful if you have several rows of data. It saves you from having to constantly highlight the data every time you need to make a calculation, which can be a pain. So in the outlier sheet, you're going to highlight cells A2 to A1176. So make sure it's not the entire row. You're going to start in A2 and you're going to highlight all the data. So the easiest thing is the Control or the Command button plus the Shift and then the down arrow key. Make sure it goes all the way down to the bottom. Then from the Data menu, you're going to click Named Ranges. So from Data, you're going to click on Named Ranges. And in the box that says Named Range 1, you're going to change it to height. So right here, we're going to change that to height. And then click Done. You do need to make sure that we're in the Outliers tab. And it's going to be cells A2 to A1167 in the Outliers tab. So now anytime you want to make a calculation with this data, we just need to type in the word height rather than highlighting all the data. And you can close that off. Another extremely important thing that you need to know that a lot of people forget to do. Anytime you filter your data, you have to copy and paste the data after you have filtered it into a separate sheet and then do calculations and graphs in that separate sheet. You cannot do calculations and graphs in the same sheet because even though it looks like the data is filtered, the calculations will still be involving the full data set, not the filtered data set. So in the calculations sheet, what we're going to do is in the Before Outliers Removed section, in cells B2 to B7, we're going to determine all of these values. Then what we're going to do is take out the outliers and see how they've changed. So the mean, so it's equals average. And now instead of highlighting all that data again, now you just have to type in height. If you type, you can type in the whole word height, or if you type in a couple letters, then you can just click there. So the average height, median equals median, comma, bracket, and we're going to find the median height. Again, you can type in the word or just type in a couple letters, then click that, enter. Standard deviation, this is still a sample, so equals STDEV, bracket, height, and the first quartile equals quartile, open the bracket, height, comma, 1. Third quartile is quartile, height, comma, 3. Now, the reason we need the third quartile and the first quartile is the formula to calculate the interquartile range is the third quartile subtract the first quartile. There's really no formula for interquartile range, so to get that, you just have to press equals and then click the cell that had Q3 and subtract the cell that had Q1, and that's the interquartile range. So we need the interquartile range for the outlier formula. So that means we need to calculate Q1 and Q3. Now, the lower fence is found by the lower quartile minus 1.5 times the interquartile range. So it's equals the lower quartile, which is cell B5, minus 1.5, and the multiplication symbol is the star, and it's times the interquartile range, which is cell B7, and then press equals. So that means the lower fence is 123.5, so any height less than 123.5 is considered an outlier. Now if you go to Plotly and you hover over here, you can see from the numbers below that it shows that the lower fence is 123.5. So any of these dots over here are all less than 123.5. Now the upper fence is Q3, which is cell B6, plus 1.5 times, which is the star button, the interquartile range, which is B7, and then you press equals, and the upper fence is 191.5. Now looking at Plotly, over here, Plotly is saying that the upper fence is just 190. And this is where I'm saying is that not everybody agrees on the exact formulas for the upper and the lower fence. It's just the one that we're using is the more common one. All right, now what we're going to do is filter the original data. So we're going to get rid of the outliers. So we're going to go back to the outliers sheet, and we're going to filter these height values. So to do that, highlight column A, and from data, you're going to click on create a filter. Then you're going to click on this button. We did this in the very first activity, so just reminding you how to filter. We're going to filter by condition, and the condition is that we are going to be between. So when you filter, you're saying what you want to keep. So we want to keep anything bigger than 123 bigger than 123.5 and less than 191.5. And you press OK. And you can see here that the graph does change, not the Plotly one because that's a different program, but the histogram does change automatically. What you might notice is if you scroll down, it still looks like there's 1,176 pieces of information. So you might think, well, there are no outliers, what happened? This is where you need to know is that this does not count how much data there is. Well, it kind of does until you filter. What it does is it just says that the number in row 1176 was 168. To see that you actually did have numbers filtered out, what you want to notice here is something like the fact that row 23 is missing. So that means whatever piece of data that was in row 23 was an outlier. So it takes out the entire row, not just the data, it takes out the entire row. So even though it still looks like there's the same number of data, there isn't. If you want to see how much data there actually is, you can click on this cell and highlight all of this data. And down here, it shows a count. There is now 1,131 pieces of data. So you can see that there was data filtered out. Now, this is where this is important. As I said, anytime you're going to filter your data, you have to copy and paste the filtered data into a separate sheet before you do any calculations, and I'll show you why. If we wanted to find the average of the filtered data, so the data without the outliers, and we just went equals average and highlighted this data, you can see that we get 155.06, which is exactly what we had before. And the reason why, when we filter the data, even though it changes the table, it does not change the calculations. So if you want the mean or any calculations of the filtered data, what you have to do is copy it and paste it into a new sheet before you do any calculations. So we're going to copy it. So highlight column A. We're going to open up a new sheet at the bottom and title it Height No Outliers. So here, add a sheet, and we're going to title it Heights No Outliers. And we're going to paste that column into A. Now if you scroll down, you'll see that there it was, only goes down to 1132. It's 1132, not 1131, because the title takes up the first row. So now this only has the filtered data. So this does not include the outliers. So if you were to calculate the average of this, now when we highlight it, we have a different mean, because before it was 155.06, now it's 157.74. So this is a part that people forget. That's why I've highlighted it, bolded it, starred it, and said important. Anytime you're going to filter your data, you have to copy and paste the filtered data into a separate sheet and then do your calculations in a separate sheet. Okay, so now what we're going to do is we're going to name this new data. So we're going to highlight the data, not the title. So we're going to highlight from cell 2 all the way down, and under data and named ranges, we're going to, you can't call it height again because you can't call it the same thing. We're going to call it no outliers, no spaces. So just no outliers, no spaces, and then click done. Now we have two named ranges. The first one was height, and that came from the Outliers tab. So that was the first tab, the Outliers tab from these cells. And the one we just named here was no outliers, and that came from the heights no outliers tab that we just made and from these cells. And we can cancel that. And now we're going to go back to the calculations sheet, and we're going to see how the mean, the median, and the standard deviation changed after we took out the outliers. So in these cells, you're going to calculate the mean, median, and standard deviation. And that's going to be using the no outliers data. So this is going to be equals average. And this is where I'm saying naming ranges is optional. If you don't want to do the named ranges, after you do the equals average, you would just click on this tab and then highlight this data, and then it would calculate the mean. But naming it just saves you from having to go back and forth from tab to tab. So it's up to you. You don't have to name the ranges. So average, no outliers, totally up to you what you want to do. If you're doing any kind of an assignment and you don't understand this named ranges thing, don't worry about it. So I'll show you that again. If you don't name the ranges to find the median, you could just type in equals median and then go to this tab, click, highlight all the data, press equals, and it will still give you the median. But if you want to use the named ranges, equals median of the no outlier data, you're still getting the same number. Standard deviation of the no outlier data. So from the, let's go over here, from the box and whisker plot, you can see that most of the outliers were low, just a couple of high ones, but most of the outliers were low. So when we take out all of these low outliers, it should make sense to you that the median would increase. Sorry, the mean increases. The median increases a little bit. Mean is more sensitive to outliers, so you're going to see a bigger difference in the mean. And because we've taken out the outliers, the standard deviation will change drastically. Now, as I said, the histogram will automatically change, but the box and whisker plot will not automatically change. So what you have to do is go to this data, go back to Plotly, and make another box and whisker plot. So you can click on this, you can go back to Plotly, and you can just put this into column B. And then in traces, what you can do is you can get rid of the first trace, add a new trace, and we're going to take it from column B, and don't forget to change it to a box plot. So get rid of the title, get rid of the y-axis. This is going to be height, centimeters. What you could do if you wanted to, in the title, you could say the height with no outliers, if you wanted to. Then under traces, you can delete that. And under points, now sometimes you will still see some suspected outliers. It happens. Not to worry about it. This is 123.5 and this is 125. It's because the data changed, so it's kind of treating this like it's a brand new data set. So with the brand new data set, it's thinking, oh, well, there's a couple of outliers in this brand new data set. But if you start taking those out and changing the data set again, it may keep finding new and new outliers. So don't worry that this is still showing that there's a couple of outliers. It's just saying if this was the data, so if column A didn't exist and there was only column B, then there might be 2 outliers. But in terms of the entire data set that we started with, those aren't technically considered outliers. So you can screen capture this and put it into the height no outlier sheet. So you can read this part, which I already talked about. You can see that the new box and whisker plot still shows that there are outliers, and that's okay. So don't worry about that. Remember that this method is only one agreed upon method and doesn't necessarily mean that that's exactly what Plotly is going to do. And again, those 2 are actually only there because Plotly is considering this as a new set of data. So that concludes part A of this activity.